Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Hadi bin Muhammad Sofian. My number matric 22B09I024. Today I'm gonna present about voltage control oscillator. Voltage control oscillator is a combination between common emitter cascade with negative feedback. Voltage control oscillator, or to be called VCOS, is a device that controls the voltage and the signal in a circuit in order to gain a stable frequency. Common emitter amplifier with current series negative feedback is a configuration commonly used to amplify and stabilize signal. It provides voltage gain and use a feedback resistor to control the gain and improve linearity. The common emitter amplifier with current series negative feedback is widely used configuration in various applications that require voltage amplification and improve linearity. The characteristic of VCOS. First one is to control the gain, whether it is voltage gain or current gain. Second is to improve the linearity. Third, to control the impedance. Application of VCOS. VCOS voltage control oscillator are widely used in applications such as frequency synthesizer, phase lock loops, PLLs, and communication system. By utilizing current series negative feedback in the VCO circuitry, the gain can be controlled and linearity can be improved, resulting in stable and accurate frequency modulation. This is the circuit design. For transistor, using the cascade method, which is placed horizontally. Transistor biasing. The transistor is biased in the common base configuration where the emitter is ground and the input signal is applied to the base terminal. Yes. The biasing network, typically a voltage divider, is used to establish the desired operating point for the transistor, ensuring it operates in the active region. For the input signal is applied to the base terminal of the transistor through a coupling capacitor, which blocks any DC bias from the input source. The input signal modulates the base emitter junction, causing variation in the base current. For transistor operation, the input signal current flow through the base emitter junction from the Q1 to Q2. Due to the common base configuration, the collector current is nearly equal to the emitter current. Yes, nearly equal. For feedback network in the current series negative feedback configuration, a portion of the collector current is delivered back to the input side of the amplifier. This feedback current is obtained by passing the collector current through a resistor connected between the collector and the base terminal. The resistor value determines the amount of feedback current. For feedback effect, the feedback current is combined with the input current at the base terminal, modifying the effective input signal seen by the amplifier. The feedback current helps control the overall gain of the amplifier. Increasing the feedback current reduces the gain, while decreasing it increases the gain. Increasing the feedback current reduces the gain, while decreasing the feedback current increases the gain. The feedback also compensates for non-linearity in the transistor and other circuit imperfection, improving the linearity of the amplifier. For the output signal, the amplified output signal is taken from collector terminal at Q1 or Q2 based on the stage. The amplified output signal taken from the collector terminal through a coupling capacitor, which blocks any DC bias from the output. The output signal is typically connected to a load resistor, which converts the current signal into a voltage signal. As you can see here, for stage 1, the channel A input is placed through the capacitor 1. And the channel for the channel B, the wire is placed through the capacitor at capacitor 3. So the current flow through this circuit and resulting the signal for my circuit channel A, the input is 1 volt and the output at channel B is negative 3.8 volt. The output is negative because the capacitor 2 at the emitter make it to the input. This is negative feedback. For stage 2, channel A is placed through the capacitor 3 for the input. For the channel B, which is output, is placed at capacitor 4. Then the current flow through the transistor 2 and resulting the signal to amplify from negative 3.2 as input at channel A, which is negative that we get from here, and then the output at channel B is 12.36 volt, which is positive value. So the input from stage 1 is positive, then the output that we get is negative. Then the negative output flow through the transistor 2 and inverted to positive. Overall stage from stage 1 and stage 2, the channel A is placed at capacitor 1 and channel B is placed at capacitor 4. Then the current flows through the transistor 1 and get from here positive, flow through transistor 1 to and get negative output and become the input for transistor 2 and invert into negative into positive output again at at capacitor 4 channel B. So the result will be like this. Channel A is positive 1.0 volt. Channel B still positive at 12.04 volt. So the signal is stabilized at the second transistor. For first transistor, it amplified the value, but the value become negative, and then the output at transistor 1 become the input at transistor 2 and amplified again, but invert the value into positive. So we get the sinusoidal signal right here. So beautiful. Conclusion, in summary, current series negative feedback offers gain control, improved linearity, and impedance control in amplifier circuit. Its applications span across various domains, including audio amplifiers, instrumentation amplifiers, voltage control oscillator, signal processing system, and control system. By leveraging the advantage of current series negative feedback, engineers can design amplifiers and systems that meet specific performance requirements and achieve desired signal characteristics. That's all from me. Thank you.